order to learn about area, we need to review sigma notation. And so sigma notation, if you remember, uses the Greek symbol sigma, which is the E. Okay, and on the next slide, I actually have something that's a little bit better. One of the things I want you to hit right here is it says the upper and lower bounds must be constant with respect to the index of summation. However, the lower bound doesn't always have to be 1. Okay, any integer less than or equal to the upper bound is legitimate. So you could start at 3, at 5, at 10. It doesn't have to be 1 at the bottom. And so this is a little better view of what sigma notation looks like. And so this is an example of sigma notation. Notice the limits of summation are n equals 1 to 5. Okay, the top limit is always on top. Yes, it is always bigger than the bottom. Okay. And n is all integers between 1 and 5. So 1, 2, 3, 4, and 5. We call n plus 1 the summand. Okay, that is what we are trying to sum. And so in purple is actually how that is read. That statement is the sum of n from n equals 1 to 5. Actually, it should be the sum of n plus 1. Sorry, I missed that. So it should be the sum of n plus 1 from n equals 1 to 5. So the sum of n plus 1 from n equals 1 to 5. So really what that means is that means that I'm going to start by plugging in 1 to this. And I get 1 plus 1, which is 2. And then what I'm going to do is plug the next number in, which will be 2. So I get 2 plus 1, which will be 3. And then I'm going to plug in 3, and I get 4. And then I'm going to plug in 4, and I'm going to get 5. And then I'm going to plug in 5, and I'm going to get 6. And that's where I stop. And if you notice, sigma notation means a sum, so I could actually add all these up, and if I add all these up, I get the number to be 20. But that is what sigma notation is, and that's a scaled down example. Now, they won't always be that easy, and so on the next slide, okay, we're going to just start with a few easy ones, and then we'll get to some more difficult ones. So let's go ahead and start. This is the sum of I from I equals 1 to 6. So can somebody tell me what that's going to mean?
1 plus 2 plus 3 plus 4 plus 6.
Right, and so then last but not least, I'm going to go ahead and add all those up. So the easy way that I do this quick is I just add up 10s. So there's 10, and then you got another 10 and 1, so you get 21. Okay, this next one, this is the sum of I plus 1 from I equals 0 to 5. So what that means is I'm going to start with 0. And if you plug in 0, you get plus
3.
And your answer again is 21. So the reason why we looked at those is because those are actually, they give you the same sum. But if you notice, the examples are different. Okay, I know my computer does that a lot. So those are the same sums, but yet if you look at the sigmas, they're different. Okay. Alrighty, so let's look at this one. This is the sum of j squared from j equals 3 to 7. Right. So basically, you're just going to do 3 squared plus 4 squared, plus 5 squared, plus 6 squared, plus 7 squared. And yes, you do need to calculate that. Okay, 3 squared we know is 9, 4 squared 16, 25, 36, and 49. So if you add all that up, you should get 135. Questions? This next slide's pretty important. You probably better get those formulas down. Okay? This is the sum of constants, integers, squares, and cubes. So I'll give you some time to write that down, and then we'll look at the next slide.
Did you watch that last night?
It's so funny on TV.
No, it was
What the
Painting Dr. Nancy.
Okay, get written down.
I love that.
It's funny. It like makes it more funny.
They like change words.
I like change that song. What do you do? Like
It was like,
when they smack that.
no, it was like smack
Hey,
that.
hey, get him down.
Let's go. Like there was like a really long pause.
It's funny too. I like that movie. What do you do? Smack that.
That's exactly what one. So
So what the heck, man?
Come on, get him written down.
I'm working as fast as I would if I wasn't talking. I'm just. Whoa.
All right, so let's go ahead and look at this. It says find the sum. Now, there is one way to do this, and that's the same way as what we did on the previous slide, and that's to go ahead and just plug in all the numbers from 1 to 30, but obviously, that does take up some time, but it's one of those things come test time. If you forget, that is an option. Okay, it's not the most efficient option, but that is an option. And so, if you notice this, we're going to use the cubed formula. So the cubed formula was n squared times n plus 1 quantity squared, all divided by 4. So in this case, and by the way, here's another thing that you need to check. When it says k equals, that number has to be 1. If that number is anything other than 1, you cannot use these formulas. Okay, it has to be 1. And so in this case, n is going to be the number on top, which is 30. So you've got 30 squared times 30 plus 1 squared, all divided by 4. Now all we need to do is calculate that. And so we know 30 squared is 900. 31 squared should be 961. And we're going to divide that by 4. So when we divide that by 4, we end up getting 216,000 what? And there you go. So obviously these do save you quite a bit of time as opposed to calculating them manually. No, I'll have them available for you. Okay, so now this one's going to be the sum of k squared plus k. And so what you're going to do in this problem is you're actually going to split the two up. So really what it's going to be is it's going to be the sum, oops, let's undo that. Yeah, it's going to be the sum of k equals 1 to 30 of k squared, and then I'm going to add to that the sum from k equals 1 to 30 of k. So it's basically like you've got two distinct problems, and then you're just going to add the results together. So if it's k squared, remember it's n times n plus 1 times 2n plus 1, all divided by 6. And then the sum for k should just be n times n plus 1 divided by 2. And so we just need to calculate those. And so 30 times 31 times 61 divided by 6, what does that come out to be? 9,455. And then 30 plus times 31 over 2, 465. So if you add those two together, your answer is 9,920.
Question,
Yes.
but on the list of examples of the equations, there's one that says C equals Cn, and there's one that says I equals the equation.
Right.
What's the
Okay,
difference?
C is a constant. That's like a number. So that would be like the sum of 5. So you would take 5 times whatever n is. So C is just a number. It's not like
That's
a
when there's
variable.
a number outside.
Right. Well, it would be like, example, this is when we would do it. We would do the sum of k equals 1 to 30 of 4. That's, and C4 is a constant. So basically what that would mean is 4 times 30. So that sum would be 120.
Oh, okay.
Okay? All right, let's go ahead and look at the last one for today. And it does tie into what you just got done asking me.
You do two split it.
Yes, you'll split it into 2 distinct parts again. The first part is going to be the sum from p equals 1 to 30 of 3, and then you're going to subtract from that. So notice that minus sign, that does follow through. P equals 1 to 30 of 0.25 p. Okay. So now 3, that's that constant one, and so basically it just says you take the constant times what n is, and in this case n is 30. And then the next one, what do you do with the 0.25? You just move that out front, and then you're going to go ahead and sum what p is. Now remember, p is n times n plus 1 divided by 2. So in this case, 30 times 31 divided by 2. Okay, so first of all, I start with 90, and then minus 116.25. So your answer is in fact a negative, and that's okay because you can sum negative numbers. Negative 26.25. All right, questions on sigma notation? All right, this is where I need you to start. Okay, I need you to start with this, page 267, 1 through 6, 15 through 22.
This person's